Hello. Welcome to my channel. In this video we are going to solve two exercises on circles in a coordinate system. Firstly, we want to find the radius of a circle of center 4 and -21/8. That is tangent to the axis of the segment that passes through the points A and B. The points A and B, respectively, have coordinates 1/2 and -1. And 2 and -4. The first thing we need to calculate is the equation of the axis of the segment AB. The axis of a segment is the line perpendicular to it that passes through the midpoint of the segment itself. The coordinates of the midpoint of the segment are given by the half-sum of the two abscissae and the half-sum of the two ordinates. We find that the coordinates of the point M are 5/4 and -5/2. Then we know that the slopes of two perpendicular lines satisfy the equation M' equals -1/m. So we can calculate the slope of the straight line on which the points A and B lie. And then we can get easily the value of the slope of the axis of the segment. The value of M is given by the ratio of YB minus YA and XB minus XA. It is worth -2. Therefore the slope of the axis is worth 1/2. At this point we know the slope of the axis. And we need to calculate the intercept. We can do it because we know that the axis passes through the midpoint of AB. We know that the axis has equation y equals 1/2 times x plus q. We insert the abscissa and the ordinate of the point M into the equation. And we find out that q is worth -25/8. We have finally obtained the equation of the line tangent to our circle. That is y equals 1/2 times x minus 25/8. We write the canonical equation of a circle of center C and radius r. And we make a system with this equation and the equation of the tangent line. We substitute the right term of the equation of the line in the equation of the circle in place of y. And we obtain a second-degree equation in x. Doing the calculations, we get 5/4 times x squared minus 17/2 times x plus 65/4 minus r squared equals 0. We multiply by 4 each member of the equation. And we get 5 times x squared minus 34 times x plus 65 minus 4 times r squared equals 0. If we want the line tangent to the circle, the discriminant of the equation must be null. We obtain an equation in R. 289 minus 5 times 65 minus 4 times r squared equals 0. This is equal to 20 times r squared equals 36. R is the radius of the circle. Therefore we want a positive number as a solution for the equation. This solution is r equals 3/5. That is about 1.3416. You can write the equation of the circle. That is x minus 4 squared plus y plus 21/8 squared equals 9/5. We draw the circle. And we can see that it is actually tangent to the axis of the segment AB. In the second exercise we want to find the equations of the circles of radius r equals 15. Tangent to the circle of equation x squared plus y squared equals 100. At the point T of coordinates 6 and -8. Firstly, we know that circles may be tangent internally or externally. So we have to find two equations of two different circles. We remember that two circles are tangent internally if they have the distance between the centers equal to the difference between the radii, while they are externally tangent if the distance between the centers is equal to the sum of the radii. Now we write the equation of a circle of radius equals 15. That is x minus xc squared plus y minus yc squared equals 225. We know that this circle passes through the point T. So we can insert the coordinates of T into the equation. We get an equation in two unknowns. 6 minus xc squared plus minus 8 minus yc squared equals 225. We solve the binomial square. Then we apply the condition of internally tangency. The distance between the two centers equal to the difference of the radii. The circle of equation x squared plus y squared equals 100 has center at the origin of the axes and radius equals 10. The other circle has radius equals 15 and coordinates of the center xc and yc that we are looking for. The distance between the two centers is given by the distance formula, and it is square root of xc squared plus yc squared. It is equal to the difference of the radii. That is 5. Therefore we get x squared plus y squared equals 25. And yc equals square root of 25 minus xc squared. Actually we should consider even the solution yc equals minus square root of 25 minus xc squared. But if you insert it into the equation, eventually you'll get the same second-degree equation. You can verify it by yourself. We substitute these two expressions in the equation of the tangent circle, and we obtain 16 times square root of 25 minus xc squared minus 12 times xc minus 100 equals 0. To solve this equation, we isolate the term with the square root. Then we square both members of the equation. We get 400 xc squared plus 2400 xc plus 3600 equals 0. We divide each term by 400, obtaining xc squared plus 6 times xc plus 9 equals 0. This is equal to xc plus 3. All squared equals 0. Therefore the only solution is xc equals minus 3. Then we substitute this value in the equation xc squared plus yc squared equals 25. And we get two possible values for yc, minus 4 and plus 4. These values correspond to two circles. The first one of equation x plus 3 squared plus y plus 4 squared equals 225. And the other equation x plus 3 squared plus y minus 4 squared equals 225. If we insert the coordinates of the point T into the two equations, we can see that only the second circle passes through the point T. Therefore y equals 4 is the solution we are looking for. We can draw this circle of radius 15 and center at the point of coordinates minus 3 and 4, and then drawing the given circle of radius 10 and center at the origin. We notice that they are actually internally tangent. Once we have found the internally tangent circle, we can move on and look for the equation of the externally tangent circle. We restart from the framed equation. That is the equation of circles of radius 15 that pass through the point T. Since we are looking for an externally tangent circle, we want the distance between centers to be equal to the sum of the two radii. The two radii are worth 10 and 15. Therefore square root of xc squared plus yc squared equals 25. We insert these values into the equation of the circle, and we get 16 times square root of 625 minus xc squared minus 12 times xc plus 500 equals 0. We isolate the square root, and we square both members. We need to solve 400 times x squared minus 12,000 times xc plus 90,000 equals 0. We divide each member by 400, and we get xc squared minus 30 times xc plus 225 equals 0. This is equal to xc minus 15. All squared equals 0. So the abscissa of the center is xc equals 15. Knowing that xc squared plus yc squared equals 625. We obtain two possible values for yc. Minus 20 and plus 20. These two values correspond to two different circles. But we can see that only the circle with center at the point of coordinates 15 and minus 20 passes through the point T. Therefore our circle has equation x minus 15 squared plus y plus 20 squared equals 225. It is the yellow circle in figure. We have finally found the equations of both circles, tangent to the blue circle at the point T. Well, this video is over. If you like my videos, you can subscribe to the channel. See you soon with another video. Bye.